Students construct a model roller coaster track out of a flexible plastic molding. They attach one end of the track to a clamp mounted on a ring stand, as shown. One student releases a steel ball of mass zero.2 kilograms at point A from a height h of 1.8 meters above the table. The second student attaches a string and a weight to the end of the ramp at point B and measures the distance to the floor to be 1.25 meters. Students want to find the speed of the ball as it leaves the end of the ramp so they can determine its kinetic energy at the bottom of the ramp. Okay, yeah. The first question asks for the procedure.
Yeah, and then also they're gonna ask you like what instrument that you have to use in order for you to capture certain values, right?
Mhm.
Like either velocity or time and stuff. So if I were you, I would. Okay, how would we determine the speed over here at the end of the ramp? You're saying something about 40 gauge, right?
Yeah.
Okay, I need to have one there, right? And I need to have another one here. Okay, what does 40 gauge do?
It just gives you the speed
Okay,
as it's going
you get
down.
V1 here, right? And V2, okay. VI here and V2 here. VF. And then
We average them out.
the average amount, right? Or you also figure out the distance from here. You figure out the time also.
Oh.
You know, like how long it takes from one 40 gauge to another, that would be time. That's procedural, okay? Now you're gonna elaborate more on what's going on with this experiment. Why did the student A have to use the clamp right here? What's the purpose of using the clamp? It has something to do with your height that you want.
Oh, they just adjust it to a certain height, right?
Yeah, for support. And you have given height right here, right?
Mm-hmm.
Okay, so now you're gonna tell me what's going on when the steel ball is going down the ramp.
Is
What happened to the speed, first of all?
it gets faster. Or
It's faster, right?
Yeah, slowly it's faster.
Okay. Okay, velocity right here versus time. Can you so from point 1 to point 2, what happened to my velocity?
It goes up exponentially, like a curve.
Okay. Remember when you do this, when you get the slope of this, right?
Yeah.
You get the acceleration, you gain the speed. So if you want to figure out the distance from this graph right here, how would you do it?
The
What do you do?
you do velocity, or you want the x distance?
Yeah,
You do the velocity times the time.
which is the area under the curve.
Yeah. This what the
So
slope?
this is equal to velocity times time, right?
Yeah.
So it will be what?
The area of the inside of
Okay.
the curve.
Area under the curve, give you that. So that's how you go from one to the other.
Mm-hmm.
Just add on things so you get complicated. Okay, now it goes right here, right?
Yeah.
And eventually, what's happening?
It goes off the cliff at point B.
Okay, I'm giving you 3 different paths. Is it like this? Is it like this? Or is it like this?
It's the middle one.
This?
Yeah.
Why not this one?
Cause that one just goes like, it just goes straight down. But it's not supposed to do that.
Okay, it's supposed to go horizontal first.
Yeah.
Okay. So now we're gonna eliminate all the things that we think is not important. So now, you tell me what's the next step. So how do we figure out what the final velocity here?
we need to. Well, first we need to find the potential. Or we need to write potential energy equals kinetic.
Yep. Is this? That right?
And that's you're trying to find the speed as it's going down the ramp.
Yes.
And that's
Which is this speed.
Yeah.
Yeah, done. Okay. By now we should be able to know it's always 2gh, right? Remember, what's the next step? The student 2 is doing something with this. Okay, what did he do? Student 2? Hello? What did he do 5 times?
Oh, he just repeated the experiment 5 times.
I know, but and he got something. Did you figure out the height? What was the height?
I thought the height was given though.
Is given? You know this one right here, right? So
Yeah.
now we're gonna go back to the kinematic equation. So I'm just gonna put them over here. So we use what?
Via initial velocity times time. Oh wait. Oh, that one.
Is this right?
1/2.
Remember G is always 10
Yeah.
for simplicity. Okay.
So if you want to find x,
Yeah.
so then the gravity and the time and the 1/2 cancel out.
You mean this or that?
Oh wait, you're trying to find the time? Or
Yeah, you have to find the time first.
Oh, so the initial y velocity and the time cancel out
Why?
because you're trying to find it in the x. Wait, no.
Remember at this point in time, I don't know if you know that your object itself is not moving up.
Oh yeah, it's 0.
Okay. So your height is equal to 1/2 g t squared, right?
Mm-hmm.
Now we accept t by itself, so
Multiply by 2, and then divide by g, and then square root by the whole thing.
okay, that would be your time.
Yep.
Once you getting the time, so what? In order for you to calculate the x distance, remember from this graph right here, there's the x, which is horizontal distance, right?
Mm-hmm.
It's also equal to VOX times time. And you know that the VOX here for the projectile motion, right? The velocity remains the same horizontally throughout the path. The only thing that is different is your vertical velocity. Remember, we should have known this one 3 years ago.
Mm-hmm.
Okay, we are at the last step. So now we're gonna go ahead and replace this one with
Square root of 2gh.
2gh times, what's the time?
Square root of 2 delta y over g.
Yeah. And whatever comes out, that will be your solutions. Pause.